If you're in block 1, you'd understand why. What's that? Once in a while, I make a couple mistakes, and I'm like, "Ooh, I'm glad I'm not taping." Well, I won't do that the next time. So take 2 is usually a little bit more successful. Okay, so today we're finishing off the unit with what will are likely a good chances that one of these will be on the diploma. They do have to have a log question that's an application. So we're going to learn the last kind of main things in science that do deal with finding the exponent. And when you look at the Richter scale, just to start, this stuff's pretty interesting. Of course, if you're not interested in geology or the Earth or anything like that, I guess it's not. But the Richter scale, whenever you hear the number 9.0, 9.2, that's 10 to the 9.2 power, okay? So that's kind of like hard to imagine, right? So why don't we start with like a 1 point on the Richter scale, and that's equivalent to 14 kilograms of TNT going off. So just think of a really, really loud explosion. That is a 1. Okay? And last year, when I was teaching this topic, Japan just had a huge earthquake. Okay? Now, Japan's on a fault line, just like Vancouver's on a fault line. Okay? Vancouver has done a lot of work trying to earthquake-proof their buildings, and especially anything that's like airplane towers and airport towers and things like that. And all their huge buildings, the way they've really done a good job is they've just designed it just like a tree would be, right? They've got their middle, right? And it's flexible. In strong winds, the building actually does move a little. Okay, brick does not do well in earthquake zones. Brick has no give to it. Okay, your cracks are, it doesn't bend a little bit. You can't just bend it a little bit and come back. Iron pipes. When you have an earthquake, like if you've ever seen anything on San Francisco, there's just fires everywhere. Okay, well, every single house has a gas line into their house, and those just snap, and there's just gas pouring everywhere, right? And something sparks it, and the next thing you know, all these buildings. So you just see that's what they're doing. They're putting out fires most times on an earthquake. Now, if you've ever been in an earthquake, it's weird. It is really, really weird. And someone explained it on TV one time, because I've been in an earthquake, and I couldn't really explain it. And she said, there's one thing we take for granted, that the ground stays still. And when that's moving on us, it's really weird, because the one thing that we've always taken for granted, always been there, it starts shaking on you, buildings start shaking, things start falling, and it's just, it's kind of gravity too. Like if gravity just changed for an hour, and things, it's something we've always just been accustomed to, and that's kind of been taken away from us right now. So they are pretty scary. This is like something that's I've never expected would ever happen before. There's a house burning down. I think we can understand that, right? I don't take for granted that my house could burn down, so we're careful around the house, right? Whenever there's the fireplace going or whatever, right? But I don't know how many of you guys have ever thought about being in an earthquake or the ground moving on you. Now, what you want to be able to do with this is you just want to be able to understand that every time you go up by 1, it is 10 times more. Okay? So an earthquake of 2 is 10 to the 2 times more intense or powerful. Okay? So an earthquake of magnitude 2 is 10 times. Okay? And they don't even really count those as earthquakes. Okay, those would be like tremors. So the excess of 6 is where we're considering that dangerous. You know, and I should get that down. I'll find out, but I don't know if Chile still stands as the most powerful earthquake. But you can see we haven't hit even close to 10. Okay? Now, how do we work with these? Okay? So these are all ratios, and if you think about them as ratios, they're quite easy. When I want to find out how many more times intense something is, I will put it in a ratio. So a earthquake of magnitude 8 is how many more times as intense than magnitude 7? Well, I would go, that's 10 to the 8, or 10 to the 7. That's how many times, how you can find out how many times more intense it is. And remember, with exponents, we subtract. Okay? So it would be 10 times. Okay? An earthquake of 10 to the 7 is how many more times it's intense as magnitude of 3? That would be 10 to the 4, which is with 4 zeros, right? So 10,000 times as intense. Okay, now let's do C. So we're thinking about this correctly. An earthquake of 4 is how many more times as intense as an earthquake of 6? Huh? It's not more intense. It's less intense. So, but maybe stick with this. Well, that would be 10 to the 4 over 10 to the 6. So that would be 10 to the negative 2, right? Which is 1 over 10 to the 2, which is 1 over 100. Okay, and I think that a good distractor on that would be negative 100. Okay, because people think, oh, it's not more intense, it's less intense. It's like negative 100. But it's not. 1/100th is actually the way we would describe that. Okay, so this would be, the magnitude of 4 is 100th times as intense as a magnitude of 6. Okay? So hopefully that makes sense. Okay. Now, here is, it's just a pen. Okay. Here is the formula they give you for comparing two intensities. Now, that looks pretty heavy duty, that formula, right? I got I2, I1s, M's, okay? We just did that. I said do it in ratio, okay? So something of 10 to the 6 over 10 to the 2, well, that's the same thing as 10 to 6 minus 2, which is 10 to the 4. What are they trying to do there? They're saying, hey, do you know that when you divide, it's the same thing as subtracting exponents? It's exactly what that rule says right there, okay? So you may see that formula on the diploma and go, never seen that formula before. Why is there's like I naughts and I twos and I ones and M's? What are M's now? Okay, so you got to keep it simple, and it's just ratios all the time. Okay, so how much more is an earthquake in Chile? How many more times intense is that than an earthquake in the 2005 in Chile, right? Well, I'm just going to go 10 to the 9.5 over 10 to the 7.8. And yes, I could go, no, that's the same thing as 10 to the 9.5 minus 7.8, but we know that, hopefully. So that would be 10 to the 1.7, which is 50. Okay, so it is 10 to the 1.7 times, so it's 50 times the magnitude. Only the end. What was the, yeah, because at 1.7 I didn't round. Yeah, well, it's 50.1 something, right? But it did ask us to round to the nearest whole number. No. You wouldn't have to round up on that one. Okay. A major earthquake is of 7.5. It was 3.75 times as intense as a minor earthquake. What would the magnitude of that one be? 375, sorry. 375 times as intense. Okay? So they've given us the answer. Exactly. So it would be 10 to the 7.5 over 10 to the x equals 375. Does that make sense? Right? I've done it in ratio. What would you do to solve this? Switch these two. So 10 to the 7.5 over 375 equals 10 to the x. If I log, I can switch places with these two, right? So this would be, I'm just going to come up here, x equals log 10 to the 7.5 over 375. And that one you wouldn't have to divide by log 10 because that's assumed. So you just go log, bracket, 10 to the 7.5 divided by 375 bracket, and you should get 4.9. Okay? So the Richter scale, remember, whenever you're given a Richter scale of 5, that means 10 to the 5. It is the exponent. Now, the next thing we're going to be talking about is the decibel scale. Now, this stuff's interesting because I think most people understand about sound and loudness and the whole thing. The units were given because of Alexander Graham Bell. I think he did a couple things in history that deal with sound, so they gave it to him. But most times it's given in decibels. Now, if you know your metric system, it is kill him dead, but don't commit murder, right? So here is decibels is, well, here's bell, and here's decibel, okay? Oops. So it falls on it is a metric unit, the bell. Now, here's something that's, the exponent will always be the bell, not the decibel, okay? So, as we go through this, you'll see that I always convert everything to bells, and then I'll convert it back to decibels if they need it, because then I can do my ratios and exponents. It makes it much easier. Okay, just to give you, here's some, like, the threshold of hearing is 0. Okay, and that's where they check your hearing, right? They put it, and they have something that's making a sound. They're like, do you hear it? Right? And then as they go up, you can see where a whisper is. Here's just a normal conversation, right here. The threshold of pain is 125. Okay, that's when it hurts a lot. Okay, a jet engine at 20 meters away is about here. Okay. Now, I was looking up some stats because when, I don't know if you guys ever remember this, but the Oilers were in the playoffs at one time. Okay. And they were saying that at the time, it was called Skyreach Center was recording the highest decibel levels of any of any hockey game going on. Okay, now even doing some reading. So the just to give you, and this is official. So Rexall was like 123 decibels. Okay, that's what sky reach was when the crowd was going wild. And it's pretty neat if you've ever. I actually found that because I was talking about this with the other class on New Year's Day a few years back. The World Junior Championships was in Edmonton, and it was Edmonton versus Finland, and Edmonton won 6-3 that game. And that is recorded as one of the loudest crowds as well. And I was in that crowd. It was the most energy that you'd ever. And also, when a goal was scored, you could, like, I mean, that place was packed. It was not an empty seat. When a goal was scored, you couldn't see one person because there were so many Canadian flags in there, and the huge ones, right? Like the superstore ones, right? And you can see it's pretty intoxicating, right? You just get into it. And it's World Juniors, so it's kind of Canada, not Edmonton, where, you know, and there was, because what happened was, because we were playing Carolina, they were trying to beat our levels because Game 7 was there. Okay, I think it was Game 4. They injured our goalie. That would have definitely given us the cup. Was it Game 2 that early? No, yeah, okay. But anyway, that's how hockey sucks, because if you're like, man, he's scoring lots of goals. Okay, let's crash the net till we break him, and then we can win the playoffs. Okay, because that's what they did. And so they were claiming, what were they claiming? 134. But I did a lot of reading. They say it's not true. They made it up, the whole thing. So let's deal with this so you can understand what I'm talking about. Now remember, 10 decibels is 1 bell, okay? So remember on here, if you have 1, this would be 10, this would be 100, and this would be, I've never heard of millibells, but it's possible. So that'd be 1,000 millibells, okay? Just like that's 1 liter, that'd be 10 deciliters, 100 centiliters, and 1,000 milliliters, okay? So it follows the same thing as the metric system. The thing that you always got to remember, though, the exponent will be in bells, right? So when you see 10 to the 3, that's 30 decibels. If you see 12, 10 to the 12.4, that's 124 decibels, okay? So you got to keep that in mind. So I find it easier just convert everything to bells and go from there if you have to change it back to decibels. Okay, so here's what I'm talking about. A power saw is how many more times as loud as a telephone dial tone. So we got 120 and 80. So I'd go, that's 10 to the 12 over 10 to the 8, which is 10 to the 4. So that is 10,000 times as loud. Okay. A jet engine is how many more times as loud as the threshold of pain. Okay, so that is 10 to the 14.5 over 10 to the 12.5. There's a really complicated formula to do these, but keep them in ratio and use bells. They're easy. Okay, they're not going to give you this formula. They're not going to give you this way in the diploma. I'll show you in a sec what it's going to look like. So that's 10 to the 2, so that's 100 times as loud. Okay? Now, a whisper is how many times as loud as a conversation? Huh? A whisper isn't louder than a conversation. Okay? So let's just do it the way that we're supposed to, 10 to the 3 over 10 to the 6. That is 10 to the negative 3. So that would be 1 over 1,000, right? 1 over 10 to the 3. So that is 1 over 1,000 times as loud as a conversation. Okay, so here, if we go all the way down, here is the formula for if you want to use decibels, okay? But in reality, you're going to end up dividing it by 10 anyway. So I just always use the Bell's formula. And this, of course, is 10 to the B1 over 10 to the B2. Okay, that's intensity. 10 to the 3, that is the intensity of that sound. And again, you kind of have to know what 10 to the 0 is because it's all relative. They've basically said 10 to the 0 would be your threshold of hearing. Okay, we're going to go do 2 and 3, both great questions. Well, 2 is very easy. 3, a lot of people would probably get wrong because of the, how to think about decibels and loudness and, or 7, sorry, example 6 and 7. Okay, so how many times more intense is the sound of playing a piano than a whisper? Okay, so easy question. That is 10 to the 6.7 over 10 to the 2.2, which equals 10 to the 4.5. And that would be 31,622. Now, don't be surprised if you get a question that easy, right? But that's not even a did you show up for class question, right? That one you might even get wrong if you didn't show up for class. Now, example 7 is a very difficult question. After you see it once, you go, okay, that's easy. Well, you have 2 telephones in a home ring at the same time. One has a loudness of 80 decibels. The other one has a loudness of 80 decibels. Does this mean that the total loudness is 160 decibels? Now, they're not going to have that part because that's a leading question. Why did they ask that? Well, okay, they wouldn't ask that if it's true. But you can bet 160 decibels will be circled. If they just gave it like this and say, what would be the total loudness together? Now, are 2 phones twice as loud as 1 phone? So are 2 people singing twice as loud as 1 person singing? Okay, that's a pretty simple question. We have people that are scared to answer that one. The answer is yes. Okay, 2 people singing is twice as loud as 1 person singing. The way that you have to think about it, though, is 2 people singing is not twice as intense as 1 person singing. Intensity and loudness are 2 different things. Okay? And this question really helps you differentiate that. So 2 telephones in our home do ring twice as loud as 1. I mean, come on, you thought that before you came in, that if you have 2 stereos going, it should be twice as loud as 1. Yep. There's going to be, no, but they would, like, the 2 would go together and make them bigger. They would not drown each other out if they were identical. Well, we'll put the 2 phones right beside each other so they go together, not on different sides so the waves kind of cancel each other out. Okay? So, this is how you do it. Now, the book fills this entire thing, all this room, just to do this question. And this is the way, if you ever get this question, now first of all, hopefully I have less people getting it wrong because of this question being on here. Okay, but this is definitely going to be one that would separate the province quite a bit. Okay, I know 160 decibels will be probably the top pick. Okay, I don't know, the student that is really discerning would go, okay, wait a minute, let's see. Okay, so remember, this is right here. Do you see this? This is 31,622 times as loud. Okay, this is actually 31,622 times as loud as this. Okay, so with that thinking, I'm going to keep it in ratio. That if I had 2 phones over 1 phone, and 1 phone was 80 decibels, then what would 2 phones be? Now, you've done ratios before. Remember, the 2 and the 10 to the x belong together, and the 1 and the 10 to the 8 belong together. Okay? So I know there's an equal sign in front, but this is 1 phone is 10 to the 8th, 2 phones is 10 to the, I don't know, but I'm going to figure it out. You don't want to put 160 in that question, because then you've done something that is very leading towards the wrong answer. So how would you solve this one? Yep. So 2 times 10 to the 8 equals 10 to the x. No, one's 2 times 10 to the x, and that was 10 to the x, right? Okay, so this is like one thing, right? So I can log this. This would be x equals log 10 and 2 times 10 to the 8th, right? So what's the answer? Plug it in. It wants it to the nearest. No, didn't even ask. Explain why or why not. Well, let's get an answer and explain. If it comes out as 16, then twice as loud is twice as intense. So x equals 8.3, or 83 decibels. Now that's not very intuitive, like as in common sense. Like I bet no one would have said, yeah, 83 decibels, that's twice as loud as 80. Okay, but it is. Okay, try it again. 10 to the 8.3. Just do it right now. 10 to the 8.3 divided by 10 to the 8, you should get the answer 2. That's twice as loud, twice as, right? So the decibels don't double when the intensity does, okay? So I would make a note somewhere, twice as loud does not mean twice the decibels. Twice as loud does not mean twice the decibels. Do not get caught on this one. So twice as loud does not equal twice the decibels. Okay, so and I think that's proven right above here. 8.3 is, or 83 is twice as loud as 80. Okay, so that's decibels. Let's go to pH. Okay, now pH, this one's going to mess with your head a little bit, because all of the exponents in the pH scale are negative, except for the first one, which is 0. Okay? But they correspond to the positive number pH. So when you get the answer 10 to the negative 13, that's very basic or alkaline. Okay? Alkalinity means basic. So you always got to be kind of aware that if you get the exponent negative 4, that means pH 4. Okay? Can you see what's going on here? So when you're doing the mathematics part, you're going to come out with a negative 6. That's 10 to the 6. Okay? Or sorry, that's pH 6. 10 to the negative 6 is pH 6. Now, okay, and you know, this strong acid, right? You guys know this. If you've taken any chem, and this one is strong base. Okay, now let's just do some of these, okay? So tomato juice is how many more times as acidic as pure water? Okay, so what I always do is I will write them underneath, or on top of them. So I got tomato juice. Where's tomato juice? So what would I write? This is 10 to the negative 4 is how many times more acidic than pure water? So this is 10 to the negative 7. Now be careful when you do these, because it should make sense when you put it into your sentence after. So this is 10 to the negative 4 over 10 to the negative 7 equals 10 to the 3, which equals 1,000. So is tomato juice more acidic than pure water? Yes. So then I would put that right in there. Tomato juice is 10,000 times more acidic than pure water. 1,000. Sorry. Okay. Now, what if I switch the words around? So what if this pure water is how many more times acidic as tomato juice? Pure water is how many more times acidic than tomato juice? Yes, good. 1 over 1,000. Okay? Now I'm going to really mess with you. What if I said pure water is how many more times as alkaline as tomato juice? It's 1,000, right? Okay, so I'll write that sentence down here just so you can kind of see. I would say tomato juice is how many times more, oh no, we're going to keep this sentence. Pure water is how many more times as alkaline as tomato juice. Okay, so pure water, is it more alkaline? Yes. So then I would be going back to 1,000. Okay. Now, eggs are how many more times alkaline than washing soda? Are eggs more alkaline? No. Okay. So you want to do your math. Eggs on top. 10 to the 8 over 10 to the 12. I get 10 to the negative 4. So what would I put in that blank? 10,000? 1 over 10,000. Yep. Yeah, you're right. Okay, so then I would get 10 to the 4. I guess the truth of it is, no matter which you put, when you get your answer, you're still going to have to ask yourself the question. If it's not more alkaline than it, you're going to use the 1 over. If it is more alkaline, see, whatever you get for your answer, 10 to the 3, 10 to the 5, whatever you get, you're still going to have to decide if it's going to be 1 over or if it is going to be just that number. Okay? Now, let's just do A here. Pure water, swimming pool water, and seawater all have pHs of 7, 7.5, and 8.4. How many more times alkaline is seawater than pure water? Now, is seawater more alkaline than pure water? Yes. So we should get a number that is not 1 over. Does that make sense? Okay? So, alkaline is, seawater is 8.4. Regular water is, pure water is 7. So then we could go 10 to the 8.4 over 10 to negative 8.4 over negative 7. See, I kind of just keep them positive because I know I'm going to have to do some thinking anyway. Because when you get this answer, you will get 10 to the 1.4, which equals 25. What does it want it to? We'll go to the, so it's 25. So it is 25 times more alkaline than seawater, than pure water. Right? Because you're going negative 8.4 minus negative 7. Nope. Oh yeah, it would be negative 1.4. So you have to decide if it's going to be 1 over 25 or 25. Yeah. It would be negative 8.4 plus 7, really. Okay? Okay. Now, so we're not going to do B. I'll actually write this sentence in here. I would say seawater is 25 times more alkaline than pure water. And pure water is 1/25 as alkaline. Okay, we can write that down. Pure water is 1 over 25 times more alkaline than seawater. Okay, so that one you just got to kind of keep straight on alkalinity. And now, question 10, for some reason, students always appreciate after I do question 10, because they're like, why didn't I know how to do that last year, or last semester, okay? Because you didn't do logs yet. So, you have seen this formula probably once or twice if you've taken chemistry. pH equals negative log H plus. Hydrogen ion concentration is moles per liter. Okay? So, we were using like inverse logs and stuff, I think, to do these, right? Okay, well, now that you know how to do these, so a patient gave a urine sample, pH 5.7. What is the hydrogen ion concentration? So all you have to do, 5.7 equals negative log h plus, right? Now, who's that negative belong to? Right, so that's negative 5.7 equals log. Now, how could I solve for H plus? Hydrogen ion concentration. Yeah, let's change this to exponential, right? So this would be hydrogen ion concentration equals 10 to the negative 5.7. Okay, what do you get? Times 10 to the negative 6. So the answer is 2.0 times 10 to the negative 6 moles per liter. So I guess maybe the chemistry teachers, they might not know how to do it this way, or they think that it's maybe too complicated to show you how to change to exponential. But now that you know how to change to exponential, it is a much easier way, quicker way to do that one. Okay, so you're doing 1, 3 to 7, 10, and 11. Okay, so the other class only had 20 minutes too, and we got most of the class done. So I'm not saying you're all going to get done, but it sure is nice to get at least 90% done or all done. It's supposed to be nice and warm. It's supposed to rain tonight. Yeah. Nothing's better than a good rain and then a freeze in the morning. Oh, it does not get better. Okay, so don't waste this time. If you're talking, you're stopping someone from working, so talk later. Okay, well, let's go. You have